My topic is all about indeterminate forms. So, let us define first about what is indeterminate forms. In calculus and other branches of mathematical analysis, limits involving algebraic combination of function in an event independent variable may often be evaluated by replacing this function by their limits. If the expression obtained after the substitution does not give enough information to determine the original limit, it is said to take an indeterminate form. So, let us always remember that there are 7 types of indeterminate form. But for this discussion, I'm gonna break down it into 3 categories, so which will be discussed later on. So, the 7 types of indeterminate forms are as follows. 1 is 0 over 0. So, in this form, when we get the limits of a certain example, it should take an answer 0 over 0. Or else, number 2, that would be infinity over infinity. And number 3 is 0 times 8, infinity. 4 is infinity minus infinity, and 5, 0 over 0. 6, 1 infinity, and 7 infinity. So, going back to the history of the indeterminate form, it was originally introduced by Cauchy student Moino on the middle of the 19th century. L'Hopital's rule. So after we see those forms in indeterminate forms, then we will proceed to LHR, or the L'Hopital's rule. So, L'Hopital's rule is a general method for evaluating the indeterminate forms of 0 over 0. As what I have mentioned previously, pag nakita na nimo nga 0 over 0 na ang answer, then or infinity over infinity, ma-apply na nimo si L'Hopital rules. Wherein ang f of prime and g or prime are the derivatives of f and g. So, we just get the derivative lang. Kuhaon lang nimo ang derivative sa certain nga limit, then substitute tong unsay x, value ni x, and then so on. Maka-come up din ka og pagkuha sa L'Hopital's rules. So, I'm gonna give you an proper example in getting the L'Hopital's rules. So, these are breakdown into 3 categories for us to easy to understand. So, number 1 is 0 over 0 or infinity over infinity. So, let us try this example number 1. Number 1 is using the limit of sine x over x as x approaches to 0 is just equal to sine. So, we got to replace the value of x to 0. So, we have sine 0 over 0, which is in line with the forms that we have discussed earlier, which is in conform with the rule that is being discussed earlier, no? 0 over 0. So, this means we can apply the L'Hopital's rules. So, how are we going to apply this one? It's just we proceed through getting the derivative. So, the original is the limit where x approaches to 0, sine x over x. So, we get the derivative first of sine. So, what is the derivative of sine x? It's basically just cosine x times 1. And after that one, we get derivative, we also proceed to the numerator of the limit, which is x. So, what is the derivative of x? Is just number 1. So, in simple form, cosine of x parenthesis 1 is just the same as cos x. So, when we get the cos x, that's the time we substitute the 0 as an x, and we all know that cosine of 0 is just 1. So, therefore, the final answer for this one is that the limit of sine x over x, where x approaches to 0, is just equal to 1. Okay, so I'm gonna give you another example. So the same application rule where 0 over 0 or infinity over infinity. So we have this example: limit of 5t to the fourth minus 4t to the second minus 1 over 10 minus t and 9 cube root of t. So where t is approaches to 1. So notice that it is approaches to 1. So we just simply substitute it directly if to test that it will apply the indeterminate forms that we have discussed earlier. So for example, 5 parenthesis 1 over 4 because we substitute 1 on it, and minus 4 the quantity of 1 to the square root minus 1 over 10 minus 1 minus 9 and then 1 square root of 3 equals to 5 minus 4 minus 1 equals to 0. So as you can see, we arrive our step 1, our answer, which is 0 over 0. So the limit for 5t for 4t squared minus 1, 10 minus t, 9t to the cube, where t is approaches to 1. So after getting that one, we have to solve it, and then we get the derivative of it. So to find the L'Hopital's rules is just simply getting the derivative of the original limit. So what is the derivative of 5t to the fourth? It's just 20t to the power of 3 because we multiply 5 times 4, that is equivalent to 20, and then subtract the power by 1, so it makes it 3. So we have 20t to the power of 3 minus 80 because 4 times 2 is 8, then minus 1 of the exponent, so that's t, and then minus 1, the whatever the derivative of a constant is just 0, so over minus 1 minus 12t over t. Okay, 21, 3, and 8, 1. So just substitute the number after we're getting the derivative already. So it's about time to substitute using the L'Hopital's rule. So since the t is approaches to 1, so we substitute 1 directly to after getting the derivative. So 20 parenthesis 1 over 3 minus 8 and 1 over 1 over negative 1 minus 27 1 squared. So we then get simplified answer negative 3 over 7. So this is the final answer, negative 3 over 7. Okay, now let's proceed to second category, which says that 0 positive to negative infinity, or infinity to negative infinity. So say for example, the limits of x, L, and x, where x is approaches to 0 to the right. So in this case, we need to verify it first. So no, if this is in line with the case or category number 2. For example, 0, because we replace 0 first since approaches to 0 to the right. So we replace 0 as x, so we have 0. And then we all know that the ln of x or the ln of 0 is, since it is to the right, so it is negative infinity. So as you can see here, this is the same in its form, is the same in category number 2. So that's why we can proceed the LHR. We can substitute 0 to that kind of example. So the limit of x to approaches to 0 or positive ln x over x negative 1 is just the same as negative infinity over 8. As you can see here, it appears to be exact in category number 1. So after category number 2, it must be proceeded to category number 1. So since we arrive at category number 1, we can apply then the L'Hopital's rule. So the limit of 1 over x, since we need to put the numerator of the original limit below the numerator, since we need to be in the fraction form in number 1. So similar in number 1, since it is reduced into fraction form, same po datong buhaton. So 1 over x over negative x to the power of negative 2, limit of 1 over x minus x to the power of 2. So cancel out. So we didn't arrive x approaches to 0, positive to negative x. So as you can see here, no, we have the reduced answer of limit x approaches to 0. So after we get the after we're getting the derivative of each, no, we can now substitute the original limit, which is 0. So it is basically 0. The final answer is just basically 0 lang. So that's it. So always remember, no, when we get to the limit, so inanion na siya, kuhaon mo ang una, imo siyang i-verify by substituting what value that is approaches, and then after that one, in getting the L'Hopital's rule, simply by getting the derivative of the original limits. So that's it for today.